Hello everyone, today we will be talking about the last section of 10.1D, and this one will be using properties of tangent. So just a reminder of what you guys learned last week. The two properties we learned about was the first, if I have two tangent segments for a circle, these tangent segments are going to be congruent to one another. And then secondly, we learned that these tangents are perpendicular to the radius of the circle. So we're going to use those properties in today's problems. So this first one says that RS is tangent to circle C at S, and RT is tangent to circle C at T. I want to find the value of X. Well, this is going to be using that first property I talked about, and that is that tangents are congruent to one another. So that means that RS is congruent to RT. So to find the value of x, all I'm going to do is set 3x plus 4 equal to 28. Now I'm going to solve for x. So I'm going to subtract 4 on both sides. And so I get 3x is equal to 24. And then I'm going to divide both sides by 3. And so I get that x is equal to 8. Okay, this next one's going to be really similar. I now, again, have two different tangents. So I have that GH is tangent to circle F, and HK is also tangent to circle F. So that means that GH is congruent to HK. So to solve for A, all I'm going to do is set these equal to one another. So I have 4 plus 2A is equal to 5A minus 32. First, I want to get all of my a's on one side, so I'm going to subtract 2a from both sides. So I get 4 is equal to 3a minus 32. And then I'm going to add 32 to both sides. So I get 36 is equal to 3a, and then my last step, divide both sides by 3. So I get a is equal to 12. Okay, and then for this last one, same process. These are both congruent to each other since they're both tangent to circle Q. So I have x over 4 is equal to x minus 6.3. Now this one's a little bit different. I have this fraction with my x. I don't like working with fractions, so in order to get rid of it, I'm just going to multiply both sides by that 4 in the denominator. And the reason why I do that is when I multiply this 4 with this x over 4, those 4's cancel. So all I'm left with is an x on this side. And on the right-hand side, I need to be careful. I need to make sure that I distribute this 4 with the x and with the 6.3. So on this right-hand side, I'm going to get 4x minus 6.3 times 4, which is 25.2. And now I'm going to go about normally. I'm going to get my x's on one side, so I'm going to subtract 4x on both sides. And then I'm going to divide both sides by negative 3. So I get x is equal to 8.4. Okay, now for these next couple problems, I'm going to use my other property that the segment that's tangent to the circle is going to be perpendicular to the radius. So this first question is asking, is DE tangent to circle C? Well, I know if DE is tangent to this circle, that there would be a right angle here because of that property. So I need to see if this triangle is a right triangle. So I need to use my Pythagorean theorem. So that means I need to check whether 3 squared plus 4 squared is equal to my hypotenuse squared. Well, I only know this part, that's equal to 2, but I do know this part as well. Since I'm going from the center to the outside circle, I know it's my radius, which I know is 3. So that means my hypotenuse is going to be 5. If you remember your Pythagorean triples, you could recognize right away this is a right triangle because 3, 4, 5 was one of our triples. However, if you didn't recognize it, we'll go ahead and go through that process. So 3 squared is 9. 4 squared is 16. I want to see whether that's equal to 5 squared, which is 25. 9 plus 16, I do in fact get 25. So this is true, so that means that yes, it is tangent. For the next problem, I'm told that ST is tangent to circle Q. So that means that this right here is a right angle because I know that the tangent segment is perpendicular to my radius. And now I want to find my radius of circle Q. So I'm going to kind of do what I did before. I'm going to use my Pythagorean Theorem. However, this time I do know it's true. And I'm going to use that to solve for R. So using my Pythagorean Theorem, I have R squared plus 24 squared is equal to my hypotenuse squared. My hypotenuse, I'm not told right out what it is. I know this part is R. Now this part is length 18. So that means this entire hypotenuse is R plus 18. So I'm going to have that this is equal to R plus 18 squared. So before we go on with this problem, I need to figure out what this R plus 18 squared is. So we're going to be using what we learned about last week when we talked about multiplying polynomials. R plus 18 squared, that just really means I have R plus 18 times R plus 18. And I'm going to use double distribution to multiply this out. So that means I need to multiply this R into here and then the 18. So R times R, I get R squared. R times 18, I get 18R. And then now I need to distribute this 18. So 18 times R, I get 18R. And then 18 times 18, I get 324. And so simplifying this out, I can combine my middle terms and I get R squared plus 36R plus 324. So now I'm going to go ahead and plug in this into my right-hand side of the equation. And so I have R squared plus 24 squared, which is 576, is equal to R squared plus 36R plus 324. My goal here is to solve for R, so I'm going to get R by itself. So first I'm going to subtract over R squared. And I see my R squares actually just cancel each other out. And then I'm going to subtract over 324. $576 minus 324 is 252 equals 36R. And then I'm going to divide both sides by 36. And so I get that R is equal to 7. So my radius is 7. Okay, now for this last problem, this is just like what we did on this other slide. I'm told that points M and N are points of tangency, and I want to find the values of X. So again, that means if I have two segments that are tangent circle, they're congruent to each other. So I have X squared is equal to 9. Now to get rid of that square on the X, I need to do the inverse function. So I need to take the square root on both sides. That leaves me with just X on this side. And then the square root of 9, we need to be careful here. We're actually going to get two answers. First, I know I have 3, but I also have negative 3. And that's because negative 3 times negative 3 is also a positive 9. And so one way we write this when we have the same number but just opposite signs, we use this plus or minus sign out in front. So you may see it like this as well. Okay, that's it for today. Your homework is on big ideas.